The atmospheric pressure on Mars is 140 times less than that of Earth. It's about 7 millibars on average at the surface. It's the same pressure we have in large depressions like in Hellas, where there is much more pressure than we would have at the highest part of the Martian orography at the summit of Mount Olympus. Its atmospheric composition is practically carbon dioxide, with a smaller proportion of nitrogen, 3% and 2% argon. Oxygen is a trace gas, meaning it is less than 1%, and it has very small amounts of water vapor. This differs quite a bit from Earth's atmosphere. The red planet has a significant difference between the northern and southern hemispheres. The north is more depressed than the southern hemisphere, which is more elevated. We can see in the image we are showing a topographic map with the different elevations colored. The bluish colors indicate deeper areas, and the reddish colors are higher areas. We can clearly see how there is a difference in height between both hemispheres. The northern hemisphere is flatter, it is deeper, and the southern hemisphere is not only higher, but also has many more craters. Its surface is much older. We think that Mars, when it was young, received a very strong impact from a planetesimal in its northern hemisphere that caused it to flatten. But we also think that in this northern hemisphere, there must have been an ocean, which we call Oceanus Borealis. This ocean caused all the asteroid debris, all the impact debris, to be cleared from its surface. That's why the southern hemisphere is not only higher, but it also has many more marks. It's as if those scars left by the large impacts were not erased in the southern hemisphere compared to the north. The region that separates the northern hemisphere from the south, that step we have talked about, is called the dichotomy. Again, it is this dichotomy that separates the deeper regions of the northern hemisphere from the higher regions of the southern hemisphere. Additionally, it is a planet with extremely exaggerated topographical features due to having less pressure, lower gravity. We have Olympus Mons, which is 3 times the height of the highest mountain on Earth, Mount Everest. Then we have a mountain in Hawaii that is even taller than Everest, but it does not manage to be taller than Olympus Mons, which is the tallest mountain in the solar system, with a height of 25 kilometers. We know it is an extinct volcano. Mars has a geologically much more active past than at present. It had a large region of volcanoes, and currently we think this geological activity is quite suppressed. Moreover, this Olympus Mons is not only very tall, but also extraordinarily wide. If we compare it with the Iberian Peninsula, you can see how an astronaut would take months to climb it. It is truly enormous. Moreover, Tahir, you can see at the bottom that great scar the planet has, what we call the Valles Marineris. It is a great canyon formed by catastrophic floods in the planet's past. We know there was a lot of water activity in Mars's past, lakes, rivers, oceans, but we think they were quite ephemeral, meaning they occurred over prolonged periods in Mars's past, but sporadically, alternating between dry and wet periods. These would be the wet periods when there were these catastrophic floods, such as those caused by this topographic phenomenon, like the Valles Marineris, which has an extension, if we compare it, like that of the United States. It is truly enormous. You can see how it even spans from coast to coast of the United States with a depth of up to 7 kilometers. It is truly an extraordinary topographic phenomenon. Moreover, we know that Mars, in its past, lost its magnetic field. We have found regions of Mars with a residual magnetic field. This means that in the past, it must have had a large magnetic field, and what we think happened is that the planet, being smaller, its interior, its core, cooled quickly. This core, hot in the Earth, we know is made of molten iron and nickel. On Mars, it must have cooled, and as it cooled, it caused convection to stop, the rising and falling of material, which ultimately is what produces the dynamo effect, what activates a planet's protective shield. Therefore, Mars, by losing this protective shield, this magnetic field, the planet, the atmosphere, was exposed to the virulent solar wind, which gradually swept away the atmosphere, and with it, a large part of its atmosphere as the pressure decreased. Today we know, for example, thanks to NASA's MAVEN orbiter, that the red planet is losing tons of atmosphere to space every day today. Imagine the amount of atmosphere that must have been lost over the millions of previous years, but not all of it. It has not been completely lost. We know there are large reserves of water, especially in ice form, underground. We have found a lot of water ice also not very deep, all over the planet. Thanks to the radars we have on the orbiters, for example, the one from the European Space Agency Mars Express, we have also found a large amount of water and the polar caps in the north and in the south. Here, I will also briefly explain how the polar caps are composed of two different layers. The surface layer, which is made of water ice, and the subsurface layer, which is composed of CO2 ice or dry ice. The surface layer of CO2 ice is less deep in the northern hemisphere than in the south. For this reason, during the northern hemisphere's summer, this layer of CO2 ice melts completely and exposes the layer of water ice beneath it. This is why the northern polar cap is the supplier of water to the atmosphere. We have said that the atmosphere had little water, but it slightly increases when this northern polar cap melts. The first layer of CO2 ice melts and exposes the layer of water ice beneath it. In the southern polar cap, this does not happen. The surface layer of CO2 ice is so thick that it does not completely melt during the southern hemisphere summer. This led us to believe, for example, for decades, that there was no water ice in the southern polar cap. However, as of today, thanks to radar data, we not only know that there is a lot of water ice in the south polar cap, but it is not exposed to the atmosphere directly at any time during the summer. As I said, this layer of carbon dioxide ice, dry ice from the southern hemisphere in the south polar cap does not melt completely. Here we have a precise image also taken by the European Space Agency's Mars Express probe of the north polar cap and here of the south polar cap. As I said, as I mentioned at the beginning, the planet's axis of rotation is tilted about 25 degrees. This causes there to be seasons. Additionally, if we add the eccentricity, which is very large, we said that the orbit around the Sun is quite eccentric. We know that by Kepler's laws, when the planet is closer to the star, it moves much faster, but more briefly. Conversely, in the farthest part, which would be the aphelion, the planet moves much slower, but for a longer time. This is why, for example, the summer in the southern hemisphere is warmer. The planet is closer to the star, the source of heat, but it is shorter than its northern hemisphere counterpart, where the planet is farther away. The summer is cooler, but it lasts longer because, again, according to Kepler's laws, the planet sweeps out equal areas in equal times. It is farther from the star, and that's why it takes longer to orbit, and that's why the summer in the northern hemisphere lasts longer even though it is colder. As I say, the planet is a very cold planet, not only because it is farther from the star, the source of heat 50 million miles farther, 75 million kilometers farther, but also the air on Earth, we are very lucky to have the atmosphere. The atmosphere on Earth is thicker, as I mentioned, and this allows heat to be retained much more efficiently. The atmosphere of Mars is lighter, more thin, and this causes the little heat that arrives compared to Earth to be lost much more quickly. We can give an example to explain it. It's like if in winter at home we turned on the heating but left all the windows open, it would be a very inefficient process because the heat would escape through the windows.